Right, my guess is that everyone got the first reason correct, yes? No issues there? All that's provided is that these two lines are parallel to each other. Right, now, once you have that those lines are parallel, then you know all four of those angle pair relationships hold true. Right? AIA, CA, AEA, those are all equal or congruent pairs of angles. And then CIA or SSI, that is a pair of supplementary angles. Well, when I look here at angles 8 and 6, here's 8 and here's 6. And those are adjacent angles that form a straight line. So what justifies the fact that they add together to equal 180? What would those be described as being? They're supplementary, but what is the relationship? Adjacent angles that form a straight line are linear pair. Good. All right, so this is definition of linear pair, right? Adjacent angles that form a straight line add up to 180 degrees. Okay, so we'll justify that as the definition of linear pair. Next relationship is angles 3 and 6 are equal. Now, when we look at angles 3 and 6, what type of angle pair is that based on the parallel lines? Opposite sides of the transversal, both in the exterior, alternate exterior angles. So by AEA, we can state that those are equal to each other. So that is the justification. Okay, so you're looking for how are these angles related, okay, and then you're describing that relationship. So then the final example, or the final statement here, is if we take angle 8 plus angle 3 equals 180. So the first thing we do is look to see, can we find both sides of this equation earlier in our proof? Well, here's 180. Angle 8 plus angle 3 doesn't exist anywhere. So we know it can't be transitive property. So we can eliminate that from the possibilities. So the next thing to look at, if you see this statement is built off of something previous, so notice it's really similar to statement 2, right? Angle 8 is just copied down, 180 is copied down. The only difference is angle 6 is being replaced by angle 3. Are those equivalent values? Yeah, we see in step 3 that angle 6 and 3 are equivalent, so we can replace this angle 6 with its equivalent to angle 3, and replacing something with its equivalent is called substitution, right? And we determined it wasn't transitive property. Replacing something is substitution. Bless you. All right, so try this second version of the same proof. We're still using this. I'm going to erase the given information here. Okay, or all that you're told is the given that these lines are parallel. See if you can identify what would justify those 4 steps if we used that for our proof. And again, all right, so here we have angle J and K are parallel. That was given to us. The next statement here, instead of it being 8 and 6 being equal to 180, this is angle 4 and angle 3. What type of angle pair is that? Adjacent angles that form a straight line, so this is, even though it's a different set, it's still definition of linear pair. And so now when you look at the next statement, angle 4 and angle 8, when you look at those angle pairs here, how are those related to each other? Same side of transversal, one in the interior, one in the exterior. What kind of angle pair is that? Corresponding angles, good. So by CA, okay, we have corresponding angles of parallel lines are going to be equal. Okay, which then takes us to our final statement, which once again, when you look at this, look to see 180 exists earlier in the proof, yes, but angle 8 plus angle 3 does not, so there's no transitive property there. So we look to see, is it built similar to another statement? Yeah, 180 here, angle 3 here. The only difference is angle 4 is replaced by 8. Is that a possibility? Are angle 4 and 8 equivalent? Yeah, so you can replace something with its equivalent, and that's called substitution only. Okay? And so that would be what you were looking for in that type of proof. All right, so let's take a look at a couple other examples of proofs that you'll see involving parallel lines. Okay, so I want you to try this 5-step proof. All right, so Step 1 is just repeating the initial state. That's always designated as given. Okay, so let's label what we have. So BK bisects angle ABC. So here's angle ABC. BK is right here. So the fact that that bisects means that these angles are the same. So as we label this, let's find that statement. So where is the statement that angle 3 is equal to angle 4? Step 2. And what justifies that? What word? Definition of bisect. Okay, so find, again, the very first thing I would do on proofs is interpret any words or symbols that are provided in the given. Okay, we still have one more given to identify, and that is the angle 2 right here is equal to angle 3 right here. So those are the information that we have given, and then we interpreted the word bisect, and we labeled the second part as well. All right, so now if we go into our proof, we can double check some other relationships here. So angle 2 and angle 4 are equal. So first thing is, look to see, do you find those earlier in your proof? Here's angle 2. Here's angle 4. Are those both set equal to the exact same thing? Yeah, they're both set equal to angle 3. So two things set equal to the same thing are equal to each other by what justification? Two things equal to the same thing are equal to each other. So that's transitive property or substitution, right? Transitive property is that property that two things are equal. If two things are equal to the same thing, they're equal to each other. That is transitive property, word for word. All right, and so now we see that angle 2 here and angle 4 here, those are equal to each other. And so the very next statement, which will often, if you see that a statement that two lines are parallel to each other, it's usually going to be based on the very previous statement. The previous statement from that is probably what's going to justify it. So when you look at angles 2 and 4 being equal, what kind of angles are those with respect to the transversal and those two lines? They are opposite sides of the transversal, both between them are in the interior, so that is called opposite or alternate in the interior. So AIA is the justification for these lines being parallel. Okay, so this is the converse, right? So the converse of AIA justifies this. We're going to use the acronym for both the converse and the original theorem. So here it's used as the converse. And then finally, the last statement is angle 1 plus angle 4 adds up to 180. So you can look and see that's not built off of any other statement, right? So we're not going to be substituting anything in. Here, this is a statement that you create from nowhere. And right now we have just a couple things that allow us to bring in the relationship that two things add up to 180. Okay, one is definition of linear pair. Are angles 1 and 4 a linear pair? Are they adjacent? No. So that's not the justification. Another way that we have that two things add up to 180 is the definition of supplement or supplementary. Do we have the word supplementary or supplement in our proof? No. Okay, now, it is true that angles 1 and 4 are supplementary because that means they add up to 180, but there is no word supplement to use as the definition. So the only other way that we really have for showing that two things add up to 180 that's not based on substituting in to a previous expression or equation is CIA, right? Are angles 1 and 4 same side interior angles of parallel lines? Or consecutive interior angles? Yes. So CIA, okay, or SSI, either of those would work for this. Okay, consecutive interior angles 1 and 4 add up to 180 because those lines have been proven in step 4 to be parallel. We proved these lines are parallel. Therefore, the same side interior or consecutive interior angles have to be supplementary. And so that would be your justification for that.